Hi everybody. In this video we're gonna go over integrating Rust into a React Native project that's using Expo, and we're gonna be doing that using the Expo Module system. So at work recently we're exploring how we want to build an app that has to call Rust code, and there's a few different options. Like Flutter makes it relatively easy. There's other app frameworks that also have maybe simpler ways of getting Rust running on the native platforms. But I was looking into how to do this specifically with React Native, and Expo being like a really good tool for developing in React Native. I was trying to get that to work, and I haven't found like a ton of information about it, so figured I'd put this video together. So in this video we're gonna go over the process of basically end-to-end creating an Expo app, creating an Expo module, creating the Rust library. It's just gonna like add two numbers, and then linking everything up so that it works. So I mean, that sounds like a lot, but I actually feel like the process is relatively straightforward once you figure it out. Yeah, so hopefully this is useful to you guys. Let's just get started. So in this video, I'm going to assume that you have some familiarity with React Native, and you can figure out how to install Rust and get everything running. So this is not like a React Native tutorial, but at a high level, you're going to need Node installed. You're going to need to install Rust. We're going to install some Rust dependencies like the iOS targets and the Android targets, because we're going to be building our application for those two platforms. You're going to need Cargo NDK to build the Android targets, and cbind gen to generate header files so that iOS knows like how to call the function that we're going to be writing. So aside from that, Xcode and Android Studio to test things out, and you are also going to need CocoaPods to do some setup for the iOS side of things. As of like 2 days ago, CocoaPods version 15, I want to say, was not working with React Native, so you might need to use it at 14, depending on if and when they fix that issue. So yeah, first things first, here I'm in this like Expo Rust directory, and I'm going to create a new Expo project with npx expo, create Expo app. And we're going to be using the TypeScript template, and it's going to be called Expo Rust demo. And side note, I feel like a lot of this video is going to be waiting for dependencies to install or things to build. So yeah, apologies in advance. Maybe I'll try to fill the time. Maybe I'll just be quiet. But for now, we're going to let this thing do its thing. Cool. So I'm going to cd into Expo Rust demo, and just to see that things worked, I'm going to run the iOS app, and we're going to get iOS working first, and then we're going to do Android. And I think iOS is a little bit easier, but yeah, at the end of the day, neither are that complicated once you know how to, once you really know where to put these files. It's mostly like naming things and moving files around. So we've got this simulator, running React Native. I'm gonna open VS Code. And here I'm just gonna make the text bigger so it's easier to see. And by that I mean in the simulator. And why don't we say font size 42? And here I'll just have this say hello world. And if we go to our simulator, cool, it says hello world. So React Native is working as it should. I'm going to close out of this, kill that process, and then we're going to make our Expo module. So we do that with npx create Expo Module, and then the name of the module, I'm going to call it my Rust module, and local because it is local to my project. It's going to ask you some questions. We can just hit enter for all of these. And cool. So what just happened is that Expo created this modules folder with the module name. And we've got like our iOS and Android source folders. Let's talk about how like the boilerplate that they give you and kind of how that works, so maybe that you can understand the Expo module system a little bit. But basically in the index.ts, I have these functions that are available to the JavaScript side of things. So for instance, I can call hello, and that's going to return something. That's part of the boilerplate as well. So if we look at the iOS folder and we look at my Rust module.swift, you can see that they give you some functions like out of the box. Here's that hello function. It returns hello world with a waving hand. So we're going to try, let's start by just trying to call the native module function. And before we can do that, we have to run npx expo prebuild. And that's going to ask you some other questions. You can just hit enter, accept the defaults. And I believe what this is doing is essentially building our modules into, so you can just see that it created an iOS and Android folder, into something that like is native. Maybe it's doing some linking. I'm not sure. I'll be honest, I'm mostly, so like the majority of my career has been in web development. I've worked with React Native in the past, but mostly still like on the React side of things, on the JavaScript side of things. Pretty unfamiliar with how the native stuff actually works. So I could be totally wrong about some of the stuff that I'm saying, but I promise this process will work. So cool, that finished. And here, currently it says hello world. Let's try to get the hello world from the Swift module rendering. So we're going to import hello from modules, my Rust module, and then just going to call that. And I'm going to do something real quick because I know that I'm going to want to do this at some point. Prettier RC. Cool. Okay, so now if I run iOS, hopefully we see a hello world with the emoji waving hello. Lots of stuff happening. A lot of this stuff too, like you like build it once, it takes a while, but then like on subsequent runs, it's a lot faster since it doesn't have to like create everything from scratch. Also, while like trying to figure out how to actually get this working, a lot of the tutorials that I found required using, like Android Studio and Xcode to do certain things in this process. You can do it all in VS Code or whatever your browser of choice is, which I think is pretty nice because I personally feel very like fish out of water in other IDEs. And I know that this is pretty close to done at this point. I'm also wondering if recording a high resolution video is not like hogging some resources. Sweet. So on iOS here, we're calling some native Swift code from React Native, which is like pretty cool in and of itself. But that's not what we're here to do. We're here to get Rust working. So I'm gonna stop this. I'm still at the root of this project, and I'm actually gonna create a new Rust library with cargo new. Yep. So cargo new. Also, side note, I'm extremely new to Rust. So yeah, really just out of my element here. But again, this works and it's kind of neat. So cargo new lib, we're going to call it native Rust lib. And that's going to create a native Rust lib folder at the root of the project. And here in my right hand terminal, I'm going to cd into native Rust lib. All right, so what did this create for us? It created this file, which has an add function, which takes a left and a right and returns, the sum. And then it has this test. We're just showing how to do this. So I'm just gonna delete the test. I'm gonna name this Rust add. And instead of usize, I'm not sure if you have to do this, but I'm gonna change this to I32. Cool. So this is going to be the function that we're going to want to call from iOS and Android. And in order to do that for iOS, we have to do a couple things. So one of the things that we have to do is add this like no mangle directive, so that Rust like keeps its name so that it can be found in the Swift side of things. And then we also have to add extern C. And that's actually it for iOS. Android's going to be a little bit more annoying, but we'll make it work. One of the things that we're going to need to do eventually, one more thing we have to do is add create type static lib for iOS. That's going to create a .a file, which is what we're going to be using in Swift world. And we need create type cdylib for Android, which I think creates an SO file. It's like the difference between a static and a dynamic library, I believe. And for Android, we need this JNI dependency, which is basically going to let us type this function using like Java types, I believe. Again, not super sure what this stuff does, but I know that we need to do it. Okay, so we've got our Rust add function. We need to build it for iOS. So let me just copy and paste some things. So for iOS, one of the things that I mentioned is that you're going to need the right targets for iOS and Android. For iOS, it's like AArch64 Apple iOS and AArch64 Apple iOS Sim. I already have them installed. But if you don't, you're going to need to install those. And then we can create our builds for both iOS and iOS Sim. And I'm in the wrong terminal there. I'm going to do that over here. And now for the simulator. And for now, we're just gonna copy, we're gonna write these commands out. In a little bit, I'm gonna show you a way to make that simpler by just using a script, because it's pretty manually doing this and moving files around is not great, but fine for iOS, but for Android, it's a huge pain. So cool. So what just happened? In Target now we have the iOS and iOS sim builds. In release we have our .a file, which is essentially like the binary that Swift is going to be calling. We need to do one more thing, or we have to generate one more thing. Using cbindgen, we need to create a header file so that Swift knows like the type definition for this. So we do that here, and also I should mention I'm gonna like write something up in the README that has all of these commands, and I'm gonna push up this repo to GitHub. So you know, I'm gonna like, you don't have to like super scrutinize these commands because they'll be available to you later. But cool, so running cbindgen created this native rust lib.h file, and it's kind of like a type definition, I believe. All right, so now we're gonna manually get iOS working, and in order to do that, we're gonna go to modules, my Rust module iOS. We're gonna make a Rust folder, and then we're gonna take the iOS sim binary, because we're testing this. We are testing this in the simulator. We're gonna move that there, and then we're gonna take that header file, and it's gonna be easier to just copy and paste it. Cool. So now our native code and the headers are in the iOS module. Got to do a couple more things. So we have to tell iOS, like, yo, go, like, use this. So in our myrustmodule.podspec, we're going to add s.vendored libraries and give it the path to the A file that we just dropped. So that's rust lib native rust lib.a. Save that. And now in our Swift file, so we looked at this earlier, right? It has like those functions that JavaScript eventually like calls. So we have to add our function here. And that is as easy as, I'm just gonna put it right under the hello, and it's this. So now we have an async function called rust add, which takes A and B, which are int32s, and it returns an int32. And this is calling native Rust. So yeah, it's interesting that like, you know, from app.tsx, you call the like JavaScript function here, which calls the Swift code, which calls the Rust code. So there's, yeah, like a lot of like, it's almost like a game of telephone. But yeah, so here's like that bridge from like Swift to Rust. Cool. So after we modify the Podspec file, remember that I said you need CocoaPods. We're gonna need to run pod install. So yeah, I don't remember if this takes a while. It does not. Nice. So, oh man, so we're missing one thing actually. So our Swift has Rust add, right? But we actually need to make that available to the React front end. So we're going to say export function Rust add, returns a number, and it's going to call my Rust module Rust add. Yeah, so kind of like how my Rust module hello is being called, and it's defined here, you know, we've got our Rust add here. So with that, we are ready to hopefully integrate that in the front end. So we're going to say Rust add, and then just going to like do a quick and dirty, yeah, like async call. So value set value use state 0. I'm actually going to say null or number, And let's initialize that to null, and then we're going to say use effect. What numbers should we add? How about 40 and 12? This takes A and B. Cool. And was that an async function? Well, I guess it doesn't need to be since this is an async function. I guess let's just follow this pattern, even though I think it would work even if you didn't do that. From what I remember, like return await is not really necessary. But anyway. Cool. So rest add async returns a promise, resolves with a number. So let's write a function here called, normally I name these do fetch. So this is going to call rust add with, really important that it be 40 and 12. Just kidding. But it's going to call rust add with 40 and 12, await the result, and then set the value here. And then here, we're going to say value equals null, loading, or the value is value. So this, I mean, if we see loading at all, it should only be for like the briefest of seconds. But we want to see the value is 52, right? Let's see if that works. Well, that's compiling. Maybe I'll talk about, like why we have to use Rust at work at all. So I work on a crypto project called Ironfish, and it's all about like privacy, keeping your transactions private, and it uses a lot of like zero knowledge proofs to do that, and a lot of those libraries happen to be in Rust, and our SDK is in Rust. So we're building a mobile wallet, and in order to use all that code, we kind of have to solve for this. So yeah, a lot of cryptography stuff happens in Rust for some reason. And check it out, this works. That's great, right? So we got the iOS side of things working. Now let's do Android. Cool. So I'm going to go here, stop the server. Clean that up. And we'll leave it around so we can test everything at the end, make sure that they both work. But I think I mentioned earlier that, like, you know, doing this, like the cargo build stuff and the moving of the files around is generally fine in iOS, but I mean, like, it is kind of annoying. So let's just take a beat and automate some of this stuff for ourselves. So I want to make a script folder, and I'm going to copy some files that I have written previously. Cool. So I've got cargo Android and cargo iOS. We're going to install TSX to be able to like run TypeScript files without compiling them. TSX is basically like TS Node, but a little bit easier to use, maybe. It seems to work out of the box more often than TS Node from what I've seen. And then finally, we're going to add our scripts to our package JSON Cool. And let's just look at what this is doing. So basically, you can pass iOS or iOS sim as the target. It's going to run, cargo build for the appropriate target. So either like AR64 Apple iOS or the sim version. So you pass it a target argument, and then it will get the target, build for that target. Well, actually, it's going to build for both targets every time. It's just going to copy the file from the appropriate place. So if you pass iOS, it'll go from iOS release, lib.a. If you pass the iOS sim, it'll do the other one. So it builds, let's see here. Yeah, so it builds both targets, generates the .h file, then, it's going to put that, it's going to copy the folders, or rather the files, to this directory, which is modules, my Rust module, iOS Rust. Figure out the source, headers path, and then just copy things over. So what we did earlier, just in an automated way, if we say npm run cargo iOS, oh yeah, so got to pass it the target. Sweet, it does the thing. Cool. So the Android one is a little bit more complicated, and I think it would probably be easier to explain if we actually run it first. So we're going to say npm run cargo Android. This one does not take arguments because unlike iOS, where we actually have to like the pod file, I think it's called, it specifies where that one specific .a file is. On Android, you actually like put all of the architecture built .so files in this one folder. Sweet. Okay, so that worked. Amazing. So what just happened is that our native Rust lib got compiled to these 4 architectures for Android. So for instance, we can look at AR64 Linux Android, which is right here. In release, we have a .so file. That's what we have to move over to the appropriate place. The destinations are modules, Android, source, main. This script created this JNI libs folder. It created the 4 folders in here for those different architectures, and then it moved the appropriate .so file into this folder. So for ARch Linux Android, it put that SO file in ARM64 v8a. Yeah, let's see. Let's just read this from top to bottom real quick. So target to destination map, how we build. This is going to take a target and build for that platform. Let's see here. Yeah, similar thing, except the big difference is that this one, iterates through the 4 different ones and like moves all of the, or I guess each of the files. Yeah, so that's what you have to do, I guess, to do this for Android. This part, like figuring this out, was surprisingly difficult. But yeah, so now we've got our files in the right place. What else do we have to do? The process now is a little bit, actually, I need to take a step back. So we just built this thing and like moved everything over, right? This isn't going to work. So, earlier I mentioned that we need like the JNI dependency in Rust because of like types for Android. So Android doesn't like understand C in the way that iOS does. So we have to help it a little bit by wrapping this function in a way that it'll understand. And I have a feeling like there's a better way to do this, but this will work. So I'm gonna uncomment that for a second. So remember that we have that JNI dependency, and essentially what it gives us is these types that are understandable or understood by the Android Java side of things. So what I did was I created this block like pubmod Android, and then in here the idea is that like as I add more functions like here, right, and I want to call them from Android, I can just like add them in this block. Not the most elegant way to do this, but yeah, so far and for the purposes of a demo, I think this works. So a couple things. We're going to add this cbindgen ignore comment so that cbindgen ignores this block because it doesn't, like only iOS uses the header file. And then we're also going to add this cfg target OS equals Android, which is basically going to ignore this when building for iOS. So before I move on, I want to point something out. So in modules, my Rust module, Expo Module config. Under Android, here we have this name, and as you can see, it is Expo, so like all lowercase, Expo Modules, my Rust module, and then in a camel case with a upper first, I don't know if that has a name, it is my Rust module. So this function right here must match that exactly, or it must match this pattern, I guess, where like the name is Java underscore and then the thing that we just saw. So I'll actually just side by side this. So Expo Modules, my Rust module, my Rust module, Expo Modules, my Rust module, my Rust module. And then underscore and your function name, and that's how you're going to refer to that function in Kotlin. Spent a lot of time not understanding what I had to do in order to get this working. This was another one of those things that, I really not documented from what I could tell. But yeah, hopefully my struggle is something you can benefit from. So just make sure that your function names follow the pattern Java, then this, but replace the dots with underscores, and then the actual function name that you want to give that when you call it in Kotlin. Cool. So now we're actually ready to npm run cargo Android, and yeah, now this should work. So we still have to like tell Kotlin though, like how to like how to call this and how to give it back to the JavaScript side of things. So here in modules, my Rust module, Android source, Java, Expo Modules, my Rust module. I feel like talking about programming and like folders and stuff sometimes is just like gibberish. But anyway, once you finally get all the way to my Rust module, you have myrustmodule.kt, which is your Kotlin folder, or Kotlin file rather, and it looks surprisingly similar to Swift. I did not know that was a thing. But in order to get this working, we've got to do some stuff. So one of the things that we have to do is we have to load the library. And we do that with this block, companion object, init system.load library, and then the Rust library name. So, cargo toml native Rust lib, native Rust lib. Cool. So we also have to, I guess, like define the function type. So yeah, this is like a abstract function. It's just a function definition, right? And then, we've got our somewhat familiar, I think the syntax is mostly the same, our hello function in the Kotlin side of things. So we can just add our Rust add function right underneath. So again, async function name, its arguments, and then it calls Rust add, and then this is the the name that we gave it here. Cool. Is this it? Am I forgetting anything? Let's see. I mean, we can npm run Android and test it out, right? And while that's happening, I'm going to go get another LaCroix. Sweet. So now we can see Android calling the Rust add function, values 52. So yeah, we now have a pretty streamlined system to get native Rust working with both iOS and Android using Expo Modules. So like I mentioned, I'm going to actually, first I'm just going to switch back to the solo view. Cool. So like I mentioned, I'm going to write a README that outlines these steps, push a repo up to GitHub, add it to the description. But yeah, hopefully this is helpful to anyone that is trying to make Rust work with React Native using Expo specifically. If you found this useful, leave a comment or reach out to me on Farcaster. I'm typeof.eth. On that platform. And yeah, catch you guys at the next one. Bye.